So for this lecture, we're going to be talking more about experiments, specifically confounding and obscuring variables. But what we're really talking about in a broader sense is the power of the study. And when we're talking about power, we're basically talking about the reverse of these issues. We're talking about how do we create a study that has more power, and by more power, we mean a greater ability for it to be able to detect differences if they're there. So we're kind of, again, on a seesaw, if you will. There's no one answer to this. The more power you have, the more likely you'll find an effect. But the more power you have, the more likely you may find effect no matter if it's there or not. So we're going to be talking about that as well. So we do want a powerful study, but we don't want to so focus on power that we find differences no matter what. So let's kind of flip this on the side, if you will, and talk about the challenges that we want to think about when we create a study. So the big question with power is, did the independent variable really cause the difference? In other words, if we found a difference, was it due to our manipulation of that independent variable, that twisting of the tiger's tail, if you will? So we're going to be talking about design confounds, selection effects, and order effects. And we've already talked about those in previous lectures. So for example, how we design our research study, thinking about those canons that we want to make sure that our design makes sure that our independent variable occurs before our dependent variable, that there's causation, we find the statistical effects, and our design rules out any other possible causes. Within that, once we've actually designed that study, we also want to make sure that we're not having a selection effects, that we're having people stay in the study throughout, and that it's the people that we actually started with that are being exposed to our study. And we also talked a little bit about how order effects, especially if we're testing multiple times, can also have an impact as people learn the measures and the tests. So here's an example of a really bad experiment, and this is really just the idea behind a confound. So the first thing is that we just do a study where we look at rambunctious behavior and the week. And we find that rambunctious behavior generally is higher at the start of the week and lower at the end of the week. So this is a standard Monday through Friday school week. We then do a study where we look at depression score, where we do pre-therapy on Monday and post-therapy on Friday, and we find that there actually is less depression at the end of the week. The problem here is that if we were just looking at study B, we would say therapy has an effect, that basically we measured depression at the start of the week and we measured depression at the end of the week. Therapy was in the middle of the week and there was less depression at the end of the week. Therapy has an effect. But the confounding variable in this case is probably that rambunctious behavior. In other words, people are probably naturally getting over that weekend or over that week from Monday through Friday less depressed as they're looking forward to the weekend. So again, we want to think about these things. We want to design studies to where we're addressing these possible confounds, and sometimes we might want to actually measure them. So we might actually measure rambunctious behavior as a control variable. In other words, we're not using it as an independent variable. We're not using it as a dependent variable. We're actually trying to adjust for that trend. And we're asking, does therapy cause a decrease in depression above and beyond the natural tendencies? We might also want to compare, for example, if we're creating a better experiment, a similar measure where people are being randomly assigned on Monday to be either get therapy or not. We then see if the people that are pre-therapy to post-therapy with no therapy show no change in depression, but those that have pre-therapy to post-therapy with therapy do show a decrease. That would also argue that we're actually finding an effect. So you can kind of see how a lot of experiments aren't necessarily bad, but they're limited. We have to get fairly complex if we're really wanting to get at that question, do we actually see the independent variable affecting the dependent variable? So these are the dirty dozen of kind of the challenges to power, and I'm just going to briefly go over each one. So we've already talked about design confounds, selection effects, and order effects. So design confound, how the study itself is designed, how the independent variable is being manipulated, when is it being manipulated, how is the outcome variable being measured, and have you ruled out any other possible explanations? We've talked about selection effects, where basically if we have people that are randomly assigned, but one group has people that select out of the study, let's say the actual intervention, and others don't, we no longer have those equal groups. And we also talked about order effects, that if someone is taking the exact same depression test, over and over and over again, or a cognitive ability test over and over and over again, they're probably going to start to learn a little bit about how to take the test better. So we're also going to talk about some new ones: maturation, history, and regression to the mean. Maturation is usually a challenge, especially when looking at people that are developing or are declining. So we're often seeing this in younger children or much older adults. So maturation effects basically mean that we've created a really good study, but that study, to be a really good study, has to take time, take effect over a period of time. So think about, for example, if we were doing an intervention on reading skills in first graders, and the study itself was 4 months long. We would have to worry about, is there a natural progression with those kids getting better at what we're actually looking at? So we need to be accounting for maturation, a natural improvement. We can also be looking, if we're looking at cognitive decline in elderly, we might also find maturation effects, especially the longer the study is. History effects are basically something above and beyond. And again, most of these maturation and history tend to be in longer studies. But history is a good example where something occurs during the study that might throw off the results. A good example of this, actually, it's a very horrible example, but during the actual 9/11 attacks on New York, there was a long-term study looking at children's fear of death. Well, the attack on New York and the dropping of the Twin Towers obviously was a history effect. There was really no way to be able to tell if the interventions were having an effect or that massive event becoming a part of the public consciousness was what caused the results that were found. Regression to the mean is often found when we're actually using extreme groups, either extremely high or extremely low. So for example, if we decide that we're wanting to study gifted children and we give them a test, and those people that are in the study are only the top 2% of the people that scored extremely highly on that test, the natural tendency is a regression to the mean. What that means is that the next time they're tested, they'll probably do a little worse. Similarly, if we took the very worst scoring students and decided that's who we were going to focus on, the tendencies would be, even without an intervention, for a regression towards the average. In other words, the people that scored the absolute worst the last time you gave them a test are probably going to score a little bit better the next time. And this is because to be the absolute best or the absolute worst, there's usually a little bit of luck beyond skill. That's not a huge change, but if we're looking for small effects, it can be a major problem. We're going to talk about attrition. So attrition, again, is more of a time-based study. The more we're doing, so we rarely see attrition if we're bringing people in, pre-testing them, doing intervention, post-testing them all in one session. Generally, we find attrition in weeks and months-long study. And again, it may be, for example, that we're actually looking at a medical intervention, and we're looking at over a 6-month period whether certain people are more or less likely to recover with a particular drug. If one group is actually having people leave the study, and in this case, in a very morbid way, they're dying, that is an attrition issue that we need to think about. Testing effects. So again, this just is basically specifically the order effects, but with testing, how we test and people's ability to learn or figure out the study and start affecting how they're behaving. And we're going to talk a little bit about that with demand characteristics as well. Instrumentation, again, typically does not happen in a single setting study, but over time, we may have a change in the instrument. So for example, many studies that look at psychological impacts, for example, use the DSM, which is the Psychological Diagnostic Manual for various mental illnesses. The problem with it is that it occasionally gets revised. So if you're doing a multi-year study and you started with the DSM-3, and at the end you're having to use the DSM-4, the instrumentation you're using to measure has actually changed. Observer bias is basically where people that are watching know what they're looking for. So for example, if I'm observing people and I'm looking for negative behaviors, I'm probably more likely to attend to those negative behaviors than I am the positives. Demand characteristics are when a study kind of lets people know how to respond. So for example, if someone starts to figure out, oh, it's pretty clear to me that over time, what you're actually testing is being overweight, and I am a body positive person, so I'm not going to give you the results, even if they're honest, that you're expecting. I'm going to actually answer the way that I politically want to. Those would be demand characteristics. And finally, placebo effects. One of the most famous studies in organizational psychology actually looked at, and this was in the 1930s and 40s, was looking at basically altering workplaces. And what they found was any alteration caused a positive effect. It really had nothing to do with changing the lighting or changing the temperature. What it had to do was the placebo effect of knowing that you were in a study, knowing you were being observed. Those are placebo effects. So for example, if you tell someone they're getting an intervention and then don't actually give them the intervention, for example, in medical pills where you're giving them, you tell them they're getting a painkiller, but they're actually getting just a sugar pill, we'll often see even the people that think they're getting a intervention do show some improvement. So again, when we're looking at these, we're just kind of thinking about the fact that, again, that regression to the mean, extremely high, extremely low is more likely to go towards the middle. We're wanting to find people that are different to begin with. So what if the independent variable does not make a difference? So the first thing we can think about is there's not enough between group differences. So ineffective manipulation. So between group differences means what we're actually expecting to see. It's the difference between that the independent variable had on the dependent variable. So if, for example, it might have just been an ineffective manipulation. So in a very gross way, think about this as far as music. If we were basically looking at the difference of two different types of pop music on study behavior, that might not find a difference. It might be an ineffective manipulation. But if we're looking at the difference with slow jazz versus quick heavy metal, that might be a larger difference, a more effective manipulation. Now, it may not tell us what's the difference between various smaller differences in music, but if we're really just looking, especially initially, for a difference that music has, for example, on study behavior, that might be something that we want to think about. We want to make sure that there is a large group difference if it's there. We might be looking at a problem with our dependent variable. We're observing. It might be insensitive. So for example, it's the difference between a single item that says, are you happy? Yes, no, versus a measure that says, are you happy? 1, extremely unhappy, 5, extremely happy. Those two are two examples of a measure of happiness. One of them, it's a 50-50. The other one has a range. And if we had 10 items that measure happiness, all on a 1 to 5 scale, all of those are going to be becoming more sensitive. We could also be looking at ceiling or floor effects on either the IV or DV. So what these means is that either everyone is scoring high or everyone is scoring low. So ceiling effects are high. So for example, if I asked, how happy would you be if I gave you $10 million? Probably everyone would say on a 1 to 5 scale, that would be a 5. They would love getting $10 million. However, if I asked, how happy would you be if I gave you $10? If you're very financially challenged, you may actually be very happy. However, if you are someone that has a lot of money, that might not even matter. So again, this kind of gives you that idea. So in that case, the ceiling effect would be the 10 million. A better measure might be $10. However, we could also ask, how happy would you be if I gave you 1 penny? Probably doesn't matter. We'd see floor effects there. There may also be the other side of the equation, too much variability within the groups. So for example, we might actually just have to where there is a difference, but there's so much variability within our various groups that we lose track of what the IV is doing to the DV. This could include measurement error, very similar to what we already talked about. So how we're measuring, especially in observational studies. Individual differences, so we haven't actually gotten rid of the individual differences through random assignment or matching. And it could also just be situational variability, noise. And we kind of talked a little bit about how true experiments tend to get rid of situational variability or noise, but at the cost of realisticness. So if I bring people into a clear lab where everyone is exposed to the exact same room, the exact same temperature, the exact same lighting, there is absolutely no change, that's getting rid of a lot of noise. However, they're also very aware they're in an experiment. If I'm secretly observing people out in a restaurant, they don't know that they're being observed. But at the same time, there might be a lot of situational variability and noise. What's on TV, what's going on, how crowded the place is, all of this could affect behavior. And finally, we do want to acknowledge that it may just be that the IV doesn't really affect the DV, that there may not actually be a difference. Not always when we find no difference is it actually a problem with the study itself. Sometimes it could be, it really isn't there. So let's talk about each one of these in a little bit more detail. Not enough difference between the groups. So weak manipulations. We can use manipulation checks if needed, rerun the study, use a stronger manipulation. So we can basically ask people, were you attending to the manipulation? Did you notice the manipulation? Did the manipulation have an effect on you? Or we could also be using a stronger manipulation. So for example, I already used the music example of two very similar types of music versus two very different types of music. It might be insensitivity of the measure. So we might use a refined scale, a better way to measure our outcome. And again, we talked about ceiling and floor effects. We could use a manipulation check for the IV, when we could also just make sure that we're actually using an IV that makes sense for our population. So again, if we're looking at logical reasoning scores, happiness one day later, and mood scores, each of these are examples of low anxiety, medium anxiety, and high anxiety. Yes, they have a little bit of a difference in logical reasoning, but it's not a huge one to begin with. And we also want to think again about the potential of other causes for what's happening. So example, happiness one day later on a mood scale, no cash, some cash, a lot of cash. We might find a relationship like this, but again, are we actually manipulating this in a way that makes sense? The other thing that we have to worry about is within group variability obscures the group difference. So at the top left here, we have an example of GRE prep score versus simply a pep talk. So someone that actually goes through the process of taking the GRE and someone that's simply just told they can do a good job and how they actually score. Now you'll find there is a difference, but we also have added error bars. And those error bars kind of tell us what's the likelihood of that difference being meaningful. Now, if we look at the bottom left, we can see that the post-test and pre-test scores of those two groups vary a large amount. So some people scored very well on the GRE score in both groups, and some people scored fairly poorly on the GRE in both groups. If we found a tighter group, so we're now looking at the right, we're still finding the exact same difference, but much smaller error bars, much more likely to find that difference. So if we can actually get our groups to focus on that manipulation and be relatively similar in how they respond, we're going to find a bigger difference. Now, this is not something we can always control, but we have to recognize that the larger amount of variability we have within each of our two groups can also obscure the difference between those means when we're looking for a statistically reliable difference between groups. So again, some of the sources of unsystematic variability, measurement error. Again, we can use a precise measure. We can measure more often. We can use those individual differences. We can have a larger sample size. We can try to match people on their cognitive skills. And we could also use a random design. And again, random designs tend to work with larger groups. We can also remove situational noise using that controlled environment. All of these are examples of ways that we can gain power. And again, we have an example here where we're looking at large amounts of variability on the outcome. And we also have two people's scores. So generally in the no money condition, Michael scored very highly. And in the dollar condition, Candace scored fairly lowly. That gives us a little bit of information, but what it doesn't tell us is what would Michael have done in the dollar condition and what would Candace do in the no money condition. So we might also want to think about a repeated measures design. In a repeated measures design, Michael is being exposed to both conditions and Candace is as well. Now, again, we might have to worry about order effects, and we may want to be addressing those as well. And one of the ways we could address order effects is it'd be also randomized whether they'd be in the no money condition first or the dollar condition first. But in this case, what we find is that, yes, Michael scored very high in the no money condition, but even higher in the given a dollar condition. And likewise, Candace scored fairly low in the dollar condition, but scored even lower in the no money condition. So we're starting to find evidence of a trend that we might have missed if all we were looking at two randomly assigned groups. So this is just a review of what we've already been talking about, all of the different things that we want to think about when we're actually looking at a study. The stronger the study is going to be, and again, I'm going to go back to that analogy of the seesaw. If we use a precise measure, if we measure a pre-test and post-test, if we have a larger design, if we pre-measured them to match or use random assignment, and we bring them into a lab for a controlled environment, we're much more likely to find a difference. But an argument can always be made, it's not very generalizable outside of that study because we took such control. Conversely, if we go out into the real world and observe this same kind of study, so we're looking at the effects of giving people money or not, we no longer have random assignment or match design. We're probably basically using a very quick measure. We're not using multiple measures. And the environment is very different in who we're getting. But if we found that difference in a controlled true experiment, and we found it later in a uncontrolled kind of natural experiment, it starts to make a stronger argument that that effect is not only there, it's findable in almost any situation. And that's why we often see multiple studies researching the same thing. So whenever we don't find a difference, the first thing we want to ask is, did we have enough power? Was our study a low power study? Could it only find very large effects? If so, we may want to go back and do another study. We may want to think about how do we increase power to look again, especially if we're fairly certain that the effect is there, we just didn't find it. We want to study with lots of power so that we can find that small effect size. Now, once we find it, we may want to focus on it with additional studies. But also, just remember, it may also be that you're wrong, that there is not a difference. So summing it up, what if the independent variable does not make a difference? The first thing we can ask about is there enough is the between group difference small enough? And the second one is there too much variability within those groups? We want to look at both of those. But at the same time, we also want to keep open the reality that it just may be there is no difference. So just some things to think about with individual differences. Do we always need a larger sample in a study? It really depends on what we're looking at and the type of study. So design should dictate how large our sample is. When might a study need to use many participants, and when might a study not need to use participants? And this is also going to be driven by the availability of the participants. If you're in a situation where you're looking at just basic human behavior and you have access to hundreds of people, then you probably want a pretty large study. But if you're interested in something that's more specific, for example, if you're looking at the effects on pro athletes, and you may only have access to 10 people, you may want to design a study that specifically looks at that smaller sample. That might also be a repeated measure study that has the need for less people. And also we want to think about the four validities that we've already talked about last week and what number of participants addresses. So again, the larger the number of participants, the more likely that we actually have random assignment, especially if we're using that, and the more likely we can generalize, especially if our samples are representing our populations. We also want to think about situational noise. What does it mean when an experiment finds a difference between groups, and even when the participants had a lot of individual differences, and where there was a lot of situational noise, and the dependent variable was measured imperfectly and imprecisely. So the first question we have to ask ourselves is, did we actually find it? It may be that just this one study through luck. We're looking at human behavior, and there's a lot of variance that goes in there as far as how people behave. The situation affects how we behave. Think about how you behave at a party versus a lecture hall. How we measure things. So again, just because we find a difference does not necessarily mean that our theory is completely supported. It may be a poor study. So what does it mean when we find a difference despite having a lot of unsystematic variability in our data? It basically means we need to do more studies. It probably tells us it's time to actually ratchet down and do a controlled experiment to find out if the effect is actually there. So the final thing I want to cover in this lecture is the Chapter 11 assignment. Regina, a master's student at a large university, wants to study music's impact on memory recall. To do so, she splits participants into two groups, the music group and the non-music group. To make things easier on herself, she studies the music groups first at 8 a.m. She plays soft music while participants read words and try to recall those words a few minutes later. Then later the same day, she works with the non-music group at 9 p.m. She has participants do the same memory task without any music in the background. She discovers the music group performed better at the recall task than the non-music group. Therefore, she concludes that the presence of soft music improves memory recall. So first, I want you to just look through this and identify the independent variable. So what is she manipulating? And what's the dependent variable? What's her outcome? I then want you to identify the design. Is it a post-test only, one group design? Is it a pre-test, post-test design? Is it within groups? Is it repeated measures? Tell me exactly what this design is. So once you've identified the IV and DV, ask, how often is she manipulating it? How is she determining who's in each group or multiple groups? And what's the outcome? And how many times is she measuring the outcome? That's going to pretty much tell you what the actual design is. Then I want you to decide whether the study is subject to any of the internal validity threats we've discussed. So think through the big 12. Are any of them actually in play in this study? And finally, indicate whether you could redesign the study to correct or prevent these internal validity threats. So that's the challenge that you have, to basically use this lecture and apply it to this particular problem to both A, identify the study, but then find the problems and how would you redesign it to get rid of those problems.